Hi, I'm Hema of 4th CE from Svecw Engineering College for Women. We are working on a project Intelligent Home Security System under the guidance of Mr. S. Hanmantrao for TI India Analog Design Contest 2012, and these are my team members.
Hi, I am Nagalakshmi.
Hi, I'm Tejashwini.
Hi, I am Divya. We are from Team A, and our problem statement is to design a second order low pass filter by making use of TL082 operational amplifier connected in unity gain configuration. For the hardware implementation of this problem statement, we are using Analog System Lab Starter Kit from Texas Instrument, which consists of analog multipliers, TL082 operational amplifiers, digital to analog converters. By using this kit, we can build large circuit like filters, differentiators, amplifiers and integrators. In this kit, we are having 4 TL082 ICs. Each IC consists of 2 TL082 op amps. Here we are using third IC, which consists of 2 spare op amps. As they are not meant for any specific configuration, so we use this IC. To build our circuit, we are going to use 2 10 kilo ohm resistors and 2 1 kilo ohm resistor. The output of first op amp, that is first pin, is connected with 10 kilo ohm resistor, and on other end 10 kilo ohm resistor is connected with 1 kilo ohm resistor, and the node is given to fifth pin. The output of second op amp, that is seventh pin, is connected with 10 kilo ohm resistor, and on other end 10 kilo ohm resistor is connected with 1 kilo ohm resistor. The output feedback is given to the sixth pin and second pin of the operational amplifier. The input is given to third pin. Fourth pin. The external supply is given to the 8th pin and 4th pin. We need to provide supply voltage for this kit. So we are using external power supply. This red wire is meant for plus 10 volts, and brown wire is meant for minus 10 volts, and black wire is for ground. Now we are going to observe three responses: magnitude response, phase response and transient response. To observe the magnitude response, we are giving sinusoidal signal of 1 volt peak to peak amplitude at 1 kHz. The input signal is 1 volt peak to peak, and we obtain the output signal as 1 volt peak to peak. At 5 kHz, there is no change in the output. At 10 kHz, the input is same as the output. And at 20 kHz, the output is same as the input. At 50 kHz, at 50 kHz, there is no change in the output. At 100 kHz, there is no change in the magnitude response. At 200 kHz, the input voltage is 1 volt and the output is 1.2 volts. At 210 kHz, the input voltage is 1 volt and the output voltage is 1.1 volt. At 220 kHz, the input voltage is 1 volt and the output voltage is 1 volt. At 250 kHz, the input voltage is 1 volt and the output voltage is 0.9 volts. At 300 kHz, the input voltage is 1 volt and the output voltage is 0.6 volts. At 500 kHz, the input voltage is 1 volt and the output voltage is 0.18 volt. At 1 megahertz, the input voltage is 1 volt and the output voltage is 0.035 volts. By using these values, we plot the graph as shown in figure. Here the cutoff frequency is 210 kHz and the gain bandwidth is 0.252 megahertz. Now we are going to observe the phase response. To obtain the phase response, the sinusoidal signal is given as 1 volt peak to peak amplitude. At 1 kHz, the phase shift is 0 degrees. At 5 kHz, the phase shift is 0 degrees. At 10 kHz, the phase shift is 0 degrees. At 50 kHz, the phase shift is 0 degrees. At 100 kHz, the phase response is 0 degrees. At 250 kHz, this is the phase response. At 300 kHz, this is the phase response. At 400 kHz, this is the phase shift. At 500 kHz, this is the phase shift. At 1 megahertz, this is the phase shift. By using these values, we obtain the phase response as shown here. Now we are going to observe the transient response. To obtain the transient response, we are going to apply a square wave of 1 volt peak to peak amplitude and 100 Hz frequency. The response is shown here. Actually, we observed a rise time 1.8 nanoseconds while doing simulation in the software, as it is very difficult to observe in the CRO because of limited range.
Hereby we can conclude that we have implemented our problem statement both in software as well as in hardware. We got three responses as magnitude response, phase response and transient response. And in magnitude response, while doing it in software, we got the gain bandwidth product as 0.3 megahertz, and when implementing in hardware, we got it as 0.25 megahertz. And we thank our college to establishing this lab and providing these kind of facilities for us. And we thank our guide for helping us in all aspects. And we thank TI Analog Design Contest for giving us this opportunity to excel in our skills.